We're here today to go across the servicing, maintenance and troubleshooting for the Rhinox HQX coupler. Continue watching to find out more about the servicing and maintenance. So there's several points to consider for the troubleshooting of the HQX coupler. One of them would be any debris that's got into the mechanism inside between the spring and also on the deadlock mechanism on the front hook. This could jam and stop the coupler from working, so it's important to keep that clear and check that throughout the working day. The HQX coupler has no greasing points, so there's no points to grease on this and there's no daily preventative maintenance. So if for any reason the HQX coupler is not working, one thing to check would be the condition of the hydraulic hoses. So these are what we would call the tail hoses that feed the coupler. If there's any damage to these or if these are trapped and nicked, it will stop hydraulic oil flowing to the coupler. One thing you can do is you can operate the coupler with the machine on and see if these hoses pulse. If these hoses are pulsing and the latch to the rear is not moving back and forth, typically it would be a mechanical issue or hydraulic issue with the coupler, as it is getting the supply of oil to the coupler. So this is the deadlock on the front pin. So this is sprung loaded. You need to ensure that there's no debris around here, any muck, any concrete, anything that's compacted up or any branches or anything that's got into here to stop this operating. This would stop the front pin from coming out should this latch not open. And again, this rear latch travels up and activates the front latch, so ensure there's no debris built up inside here. So the HQX coupler is fitted with a pilot operated check valve. It's this item here. This is to ensure that the coupler holds hydraulic pressure in the event of a system failure or a hose getting cut or burst. This could cause an issue. This could stop the coupler operating should the seals inside here go. This would need to be removed and checked. If you've checked that there is a hydraulic supply going to the coupler, it's free of debris and there's no visual mechanical defects, you'd be best off contacting a plant specialist who would be able to check systems such as in the cab, the control system and the hydraulic systems. So we're going to have to remove this feed hose here. This is to get access to the ports for the tail hoses. So we'll remove the side port. As we undo that, just slowly remove that just in case it's under any hydraulic pressure. And let any pressure escape first. It's worth having a rag just underneath there as well to capture any fluid. We're then going to work our way across, so we'll take the first hose off and fit in, which will allow access. We'll remove this one. We'll then fit the blanking plugs. And then we can refit the feed hose. It's important to consider once these hoses have been removed, until they're reinstated with the blanking plugs, don't start the excavator, as this would cause a fluid leak. Next we will use an impact gun. We'll remove the retaining screws for the pins at both sides. And to start with, we'll remove the front pin. We'll use a soft-faced hammer and a rod just to bring the pin through, taking care when we remove the pin that the coupler doesn't swing into us. We can then drop the excavator down and we'll remove the rear pin. This is obviously free to swing. Before doing that though, we'll just move the hoses out of the way. We can then lift the arm up clear away from the excavator. When we come to stripping the coupler down for any maintenance tasks, or if we need to change any parts in it, there's a few things to point out. So to the rear latch, we have a cover that actually covers the nut inside. So this purely is just to cover and just to stop any dirt and debris getting into that cover. You'll need a large adjustable spanner and possibly just a soft-faced hammer just to move that off. That can then be removed, which then gives access to a nut, which is typically an M16. On most couplers, the larger ones go to M20. We can then put an extended socket on in there and remove that, which actually removes the latch. So we'll use an impact gun to remove the nut. This then allows the latch to come free and also the coil spring. To put that back together, insert the coil spring over the cylinder, we'll then feed the latch in. Place the washer on, and then we'll just start the nut by hand to start. and then that's the rear latch fitted. So as simple as that, the rear latch can be removed. We'd then Loctite the cap on the rear and just give that a little tap to tighten it up. Then if we need to remove the cylinder, we'll follow some of the same steps that we did when we actually installed the coupler. So first we've got to take out 2 of the screws on these bosses to let the bosses lift over. This gives us access to the 4 bolts on top of the cylinder. This is only applicable on the smaller couplers, as the larger ones there is access to the cylinder screws. So we'll just start off with a ratchet, and then we can actually remove screws by hand, it's much quicker. This allows us to move the bosses over. This then allows us to move the cylinder and latch assembly out of the coupler. However, it won't come out at the moment because the tail hoses are obstructing. So we'll remove them with a 14mm spanner, ideally a ratchet spanner. That way, much easier to remove. If you still have them, it would be worth fitting the blanking plugs back in that was supplied with the coupler at new, just to stop any debris getting into the coupler. This could cause other issues by blocking the oil ways or get any contamination and any debris into the check valve. They don't have to be done up fully tight, but just to cover the hole and stop any debris getting in. This will now allow the latch and the cylinder to slide free as one unit, and this gives full access to the coupler, and we can then see the front deadlock as well. So when the deadlock needs removing, there's 2 locating screws here. They're cone-pointed set screws, so you remove them and there's actually a little dimple into the pin which holds the pin secure. They would need to be removed, and then you could remove the circlip on the outside at one side. That would let the pin come through and release the deadlock. Just take note that when you do remove this, these springs could be under tension, as they do locate under the bottom of the deadlock, and they do need to go back in the same order as they are handed. So as you can see here, both of the long arms of the spring are pointing inwards and meet each other. They must meet this face here when it's back in operation. This is the pilot operated hydraulic check valve. This maintains pressure within the cylinder should you have a system failure, such as a burst hose or a fitting to come loose. This stops the cylinder compressing and keeps the coupler locked. You could experience some issues with this. It has a series of small seals in there. One of the seals could have gone, which will stop the check valve operating as intended, or the check valve could actually be sticking inside. So to remove that, it'd be best to remove the blanking plugs. This removes any pressure within the cylinder. Then with a 22mm spanner, we'll free the check valve off. Again, just be careful when removing this in case the cylinder is still under pressure, and we can remove that there. As you can see, there is a series of O-rings, and if one of them has failed, it can actually block the check valve inside itself, or you could have some debris in these small little oil chambers here, and that would stop the check valve from functioning. One thing to consider before removing that check valve is that the cylinder is extended. If the cylinder is compressed when you remove the check valve, the spring will force the latch back, extend the cylinder, and it will eject oil from here when you do remove that. The oil that you can see here is just what is inside the cylinder, the residual oil. Before we reinsert that, obviously we would check that the seals are fine, that there's no debris on here, and the threads are all in good clean condition. When we actually reinsert this, it's best to actually have a little bit of oil around there. That just lubricates the seals as we insert that back in. We can just tighten that up. We can then just put the caps back on. And then in reverse, we will feed the cylinder and latch, just taking care you don't put your fingers around the slot area. So before we put the cylinder back in, we will refit the tail hoses. This is due to how tight the fittings are to get in on the smaller couplers. On some of the larger ones, the cylinder doesn't need to be removed. So we'll just put these in hand tight for now until we've tightened the cylinder up, as we can then position the hoses in the best place. So what we'll do now is we'll push the cylinder and the latch assembly up, but we also need to make sure that the deadlock is in the correct position. So we need to push the deadlock forward, and then we can push the cylinder up so it lines up with the holes. We'll just start the screws off by hand first, just to make sure that we don't cross thread them, and then we'll tighten them up with the impact gun. What we'll do now is we'll put the screws back into the bosses, and then this can go back onto the excavator. So again, we'll start these by hand, and then we'll just tighten them up with a ratchet. So we'll now tighten the tail hoses up. On this particular model, they just need splaying out to the side a little bit just for clearance. So we'll use a 14mm spanner to tighten the 8th BSP banjo. The 8th BSP banjo is used as standard across the Rhinox range for the cylinder ports that we're tightening here. The Rhinox HQX coupler is now ready to be refitted to the excavator. For a more in-depth guide of how to install the Rhinox HQX coupler, check out the video here. If you have any more questions and queries regarding the Rhinox HQX coupler range, don't hesitate to contact us.